Hello, my fellow friend. My name is Ahmad Faiz Nurbin Muhammad Mavlan from Computer Engineering, and with my partner today, Ahmad Hafiz bin Shahrizan, we're gonna talk about the DC motor. Now, let's jump into it. A DC motor is any of class of rotary electrical motor that convert direct current, electrical energy into mechanical energy. The most common type rely on the forces produced by the magnetic field. Nearly all type of DC motor have some internal mechanism, either electromechanical or electronic, to periodically change the direction of current in part of the motor. There are 8 parts in the DC motor. First, brushes, rotor, commutator, field winding, armature winding, stator, yoke, and poles. For brushes is a bridge to connect the static electrical circuit to the rotor with the commutator. And for rotor contains coil winding that are powered by the DC current, and the stator contains either permanent magnet or electromagnetic windings. When the motor is powered by DC current, a magnetic field is created within the stator, attracting and repelling the magnet on the rotor. For a commutator assures that the current from the generator always flow in one direction only. Commutator pick of the current generated in the winding, reversing the direction of the current with each half turn, serving as a mechanical rectifier to convert the alternating current from the winding to unidirectional direct current in the external load circuit. For field winding is an insulated current carrying coils on a field magnet that produce the magnetic field needed to excite a generator or motor. For armature winding is the winding in which voltage is induced. And for stator is the stationary component of electromagnetic circuit in motors. In different configuration, stator may act as field magnet that interact with the rotor to create motion, or as armature that work with moving field coils on the rotor. And yoke is a magnetic frame made of cast iron or sometimes steel, which work as a protector. This protective cover keeps the inner part of the rotor safe and sound, and also support the armature. Yoke also houses the magnetic poles and field winding of a DC motor to help supporting the field system. And for poles, lastly, have a 2 part. The pole's core and the pole's shoe. These 2 parts are fixed together by the hydraulic pressure and are attached to the yoke. So, how the DC motor work? So basically, the working principle of a DC motor is that whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical forces. A direction of this force is given by Fleming's left-hand rule, and its magnitude is given by F equal BIL, where B is magnetic flux density and I is current, and L is the length of the conductor within the magnetic field. When armature winding are connected to a DC supply and electric current set up in the winding, magnetic field may be provided by field winding or by using permanent magnet. When current carrying armature conductor in 90 degree position, the armature connected to positive terminal will move up, and armature connected to negative terminal will move down due to electromagnetic induction. When current carrying armature conductor in 180 degree position, the armature is nearly perpendicular to the magnetic flux. There will be an irregular motion of the rotor where the acceleration of the rotor decreases and making the speed inconstant. To overcome the problem, add one more loop to the rotor with separate commutator pair for it. In this arrangement, when the first loop in the vertical position, the second loop will be connected to power source, so the motor force is always present in the system, and armature conductor in 270 degree and 360 degree will follow the same action as well, and commutator is made segmented to achieve unidirectional torque.
Now we will be discussing about the motor types. There are different types of DC motors. This is because it is used for different types of applications. Now, the first is permanent magnet motors, which contain permanent magnet poles. Second, the field winding and the armature winding for the separately excited motors are excited separately. Thirdly, we have self-excited motors, them being shunt excited, where the field winding is connected in parallel to the armature. Then we have the series excited, where the field winding is linked in series with the armature, as mentioned by its name. Thirdly, we have the compound excited, where it's basically the combination of both series and shunt excited motors. Short shunt and long shunt are two types of shunts that can be derived from this. The short shunt for its armature and field winding are connected in parallel. The armature and field coil are then split in sequence, while long shunt, both the series field coil and the armature are attached in parallel to the field coils. Then, for motors based on that excitation, we have cumulative and differentially compound DC motors. Cumulative compound having a large startup torque and strong speed control. Differentially compound, the shunt winding and armature magnetic fields are connected where they have opposite polarity. Now, for speed control, there are three known speed control types, such as armature resistance, armature voltage control method, and field control method. Now, this can be divided into two parts for series and shunt types. For resistance method, basically shunt and series use a variable resistor or a rheostat, where basically they change the resistance of the circuit, thus affecting its speed. Now, for the voltage method, for the series type, they basically use a variable voltage source, the same as the resistance type before. That is for the series type. While for the shunt type, it is called the Ward-Leonard technique, where basically the DC supply is coupled to the shunt field winding, and the speed is controlled by the output of the voltage generator. Now, for the field control type, for the series motors, it can be divided into two parts. First being called the field diverter control, where the diverter is in parallel with the series field winding. The second being tap field control, in which the number of field turns is swiped to make it ampere turns. Thus meaning by changing the current flowing through the field or the resistance, it will change the speed. That is for series types. For the shunt types, they will use a rheostat which is linked in parallel to the field winding and will change the speed. Now, we will be discussing about the DC motor starter. The DC motor starter is basically an external resistor added to the DC motor circuit. This is because a huge current will flow through at the beginning of the DC motor. Thus, to prevent any damage, there will be added an additional resistor. Now, commonly there are three types of DC motor starter, called the 3-point starter, the 4-point starter, both for shunt, and then the series starter motor. Now, for the 3-point starter, it has a variable resistance to restrict starting current. The reason it is named this is because there are three terminals connected, such as the armature, the field, and the line terminal. Now, for the 4-point starter, it's basically the same as a 3-point starter, just with an additional terminal connected, which is connected to the no voltage coil, which is called N. This is mostly used for operating the motor above average speed. Now, for the series type of starter, they use 4-point starter with unconnected F terminals, with a few rules, such as the starting current does not exceed the current for starting resistor. This device has two terminals being linked with the positive supply and the handle. Sometimes this device is also called the 2-point starter. That is all for the DC motor starter. Conclusion. Basically, a DC motor is a type of mechanism that converts direct current electrical energy into mechanical energy. This means that any type of motor, as long as it uses direct current, can be called a DC motor. Now, in a DC motor, the main component part is usually the commutator, where it helps to create a constant rotational speed, making it thus called a DC motor. With that in mind, there are different types of DC motors that are used for different types of applications. Thus, the biggest advantage of a DC motor is its wide range of use for its speed, because for a DC motor, the speed can be controlled accurately, either from below average or higher or above average. It also has a great startup torque because of its starting method. Despite its limitations, such as requiring constant maintenance, DC motor has been proven necessary for circumstances that need accurate speed for either big machines, either small machines, for everything that you need to have accurate adjustments. That is all for the DC motor. Thank you.